Hi there, and welcome to our presentation. My name is Hannah, and you will be hearing from myself and my teammates, Peyton, Jackson, and Amay, about a project that we have been working on this semester in our team design course. Our team name is AWEAR Diabetic Solutions, and the project that we have been working on is called the Sensational Sock. The basis of our project is to help those with diabetes monitor their foot health and prevent ulceration of the foot due to diabetic peripheral neuropathy. 30 million people in the United States have diabetes, with the CDC estimating that 13.2% of the population has diabetes if we take into account undiagnosed cases. Of those people, 50% will develop some form of diabetic peripheral neuropathy, and of that portion, 50% will develop an ulcer or ulcers in the foot. You may be wondering what diabetic peripheral neuropathy is. It is a condition that develops due to chronically high glucose levels, in which these high glucose levels cause a loss of sensation in the nerves in the distal limbs, most commonly the hands, the feet, and the calf. So these free glucose levels can impose unfortunate effects on the body. An additional component to keep in mind is that those with diabetes have an increased rate of tightening of the calf muscles due to free glucose. So this can change how a person walks, and from there that will create localized pressure points in the foot where ulcers can develop due to anatomically unfavorable ways of walking. There are treatment methods that exist for ulcers, most commonly offloading the foot in total contact cast. We want the person to not be putting weight on the foot where ulcers are developing so that they can heal over time, but not only is it cumbersome and annoying not being able to walk, but it also doesn't take care of the source of the problem. For once the ulcer goes away, the person will begin walking again, and they will still have these pressure points, and an ulcer will just come back. It is from here that we developed our need statement for this presentation and for the purposes of our project. Individuals with diabetic peripheral neuropathy need a way to improve gait control and encourage ideal anatomical pressure distribution on the bottom of their feet in order to prevent ulceration. You will now hear from my teammates, Peyton, Amay, and Jackson, talk about our device, the Sensational Sock.
Our solution to address this need is an everyday wearable device called the Sensational Sock. The device is designed to measure the pressure distribution on the bottom of patients' feet and alert the user if the pressure exceeds a certain threshold, which may put them at increased risk for ulceration. Our device alerts the user immediately using vibrational haptic feedback and provides a summary of activity in the form of daily, weekly, and monthly report. The device includes 6 force sensors integrated into a diabetic sock. The force sensors are strategically located to monitor pressures in target locations of the foot where ulceration is most common for patients with diabetic neuropathy. There's 1 force sensor on the big toe, 1 on the heel, and 4 distributed across the metatarsal heads. The force sensors are connected by a conductive thread to a detachable Arduino and power source. The Arduino is connected to 6 vibrational tactors, which each correspond to a single force sensor, and vibrate if that sensor reaches a pressure that exceeds a set threshold. This haptic feedback mechanism is an optional component of our design, which will alert users of unsafe pressures immediately and may even help encourage proper balance in those who have lost feeling in their feet. In addition to haptic feedback, the Sensational Sock continuously collects foot pressure distribution data, which is transmitted to an application that consolidates the data in the form of daily, weekly, and monthly reports.
To complement the circuitry and other electrical hardware, the need for an interface between patient and device is apparent. As the Sensational Sock is a device that patients and physicians can use to obtain data about their own gait cycles, we designed a user-friendly application that individuals with diabetic peripheral neuropathy can use to track their own foot health. Designed in Android Development Studio, this application was made to increase user accountability, device accessibility, and data transparency. The mobile/tablet application for the Sensational Sock communicates with a Bluetooth module on the Arduino microprocessor. It allows a user the ability to turn an Android device's Bluetooth settings on or off, search for the Arduino connected Bluetooth module. Once a user searches for discoverable Bluetooth devices, the Sensational Sock application allows the user to connect to these devices. Making use of the Arduino's data storage capabilities and the application's own data analysis capability, which is written to the code of the application, A user can view the live data received by the Arduino, then also view gradual changes in their pressure distribution and gait data plotted against time. Lastly, the application will be provided with a basic degree of analysis, programmed in an integrated development environment for the Android operating system, capable of identifying and showing to the user certain gait abnormalities indicated by poor or improper weight distribution.
To develop the Sensational Sock, we created a series of prototypes which proved the feasibility of different components of our design. Our first prototype integrated the 6 force sensors into a shoe insole. The sensors were connected by an Arduino to 6 vibratory tactors. With this prototype, we were able to prove that we could generate a vibratory response with an intensity proportional to the amount of force placed on a given sensor. Our second prototype was designed to investigate the feasibility of using a removable external casing around the sock, which would house the force sensors. We tested this using a rough prototype where the casing was made of saran wrap. Although we were able to get force sensor readings, we ultimately decided that our final design would directly integrate the force sensors into the sock. Finally, our third prototype proved that we could collect data on all target locations of the foot when the force sensors were attached directly to the sock.
In order to ensure that our device functions correctly, we underwent a series of testing of the Sensational Sock. Our primary objective was to determine if we could receive quantitative readings from force sensors. Moreover, we wanted to be able to quantify independent values for each sensor and produce a visual representation of this data. We utilized a MATLAB code which read in the sensor values in real time and adjusted a bar graph for the bar representing each sensor as we introduced variable forces. As you can see in this video, the bars change almost instantaneously as forces change on each sensor. The red line is the threshold value, which is arbitrary in this test, but in practice, this value will be the trigger to alert the user that they are reaching dangerous levels. Once proof of concept was achieved, we transitioned our efforts to calibrating the system. Sensors output voltage values, which need to be converted into units of force. By introducing known magnitudes of force and recording the voltage values outputted, we are able to create a calibration curve. Using the equation derived from the calibration curve, we can now accurately estimate what values of force are being experienced on the bottom of the foot. We then began testing with the PDAR system, a commercial device used to quantify foot pressures. The goal was to validate that our system was recording correct values of force, but due to the transition to remote work, we were unable to complete this testing. The next step is to move into the fabrication phase so that we can conduct more robust testing. One priority is embedding the sensors into the sock. We plan to do this by sewing the sensors into the bottom of the sock and utilizing a sealant to keep out water. Additionally, we plan to transition to smaller electronics by designing a printed circuit board, or PCB, to replace the Arduino to fit in the control band around the ankle. Furthermore, we plan to utilize conductive thread to embed the wires into the design and ensure that we do not introduce any additional pressures to the user's foot. Finally, we plan to design a detachable mechanism to remove the control band from the sensors and the control band from the tactors. This will make the device machine washable and allow tactors to be optional. Additional testing needs to be conducted following fabrication to validate the functionality of the device. First, PDAR validation must be continued. We also plan to test whether the Sensational Sock creates an additional pressures in the bottom of the foot using the PDAR system. If additional pressures are created using the device, then it defeats the purpose of the device, to provide information to the user and medical personnel to reduce ulceration. Further, we must test machine washing to ensure that it can be washed and determine how many times before functionality is compromised. Finally, we will move into the clinical testing where we will compare pressures in healthy individuals with those in individuals with diabetic peripheral neuropathy in order to identify how abnormal pressures appear in the data so that we can most effectively identify them in real time and alert medical personnel.
Thank you so much for watching our presentation, and please check out our website for more information about how we came up with this project and the development of it through prototyping, testing, and you can learn more about our future work and our service learning connection with the American Red Cross. We owe much of our accomplishment to our fantastic professors, Dr. Catherine Raymond and Dr. Michael Danczak, as well as our classroom TAs, Scott and Efsheen. Also, we would like to extend our thanks to our academic advisor, Dr. Timothy Schuler, and our industry advisor, Dr. James Monroe-Laborde, without which this project would not have gone off the ground. And also, thank you to LaRonda Hartford for connecting us with the American Red Cross for our service learning project. And thank you to everyone who showed up today to watch.